we're going to start our discussion of databases in Chapter 1. It's on database systems themselves, design, implementation, and management. Good decisions require good information that is derived from raw facts. These raw facts are known as data, and data are likely to be managed most efficiently when they're stored in a database. Databases evolved from computer file systems. Although file system data management is largely outmoded now, understanding the characteristics of these file systems is important because file systems are the source of serious data management limitations. In this chapter, we will also learn how the database system approach helps eliminate most of the shortcomings of file system data management. In this chapter, we will look at the difference between data and information, what a database is, the various types of databases, and why they are valuable assets for decision making, the importance of database design, how modern databases evolve from file systems, about flaws in file system data management, the main components of the database system, the main functions of a database management system, or a DBMS. So to understand what drives database design, you must understand the difference between data and information. Data is your raw facts. The word raw indicates that the facts have not yet been processed to reveal their meaning or turned into meaningful content. Information is the result of processing raw data to reveal its meaning. Data processing can be as simple as organizing data to reveal your patterns, or as complex as making forecasts or drawing inferences using statistical modeling. In this information age, production of accurate, relevant, and timely information is the key to good decision making. In turn, good decision making is the key to business survival in our global market. We are now said to be entering what is known as the knowledge age. Data is the foundation of the information, which is the bedrock of your knowledge. That is the body of information and facts about specific subject matter. Knowledge implies familiarity, awareness, and understanding of information as it applies to your environment. A key characteristic of knowledge is that new knowledge can be derived from your old knowledge. So if we summarize key points here, data constitutes the building blocks of information. Information is produced by processing your raw data. Information is used to reveal the meaning of data. Accurate, relevant, and timely information is the key to good decision making, and good decision making is the key to organizational survival in our global market. Timely and useful information requires accurate data. Such data must be properly generated and stored in a format that is easy to access and process. And like any basic resource, the data environment must be managed carefully. Data management is a discipline that focuses on the proper generation, storage, and retrieval of all of your data. Given the crucial role that data plays, it should not surprise you that data management is a core activity for any business, government agency, service organization, or charity. Efficient data management typically requires the use of a computer database. A database is a shared, integrated computer structure that stores a collection of end-user data and metadata. Your end-user data is the raw facts of interest to the end user, and your metadata is data about your data, through which the end-user data are integrated and managed. Metadata describes the data characteristics and the set of relationships that links the data found within the database. For example, the metadata component stores information such as the name of each data element, the type or value of that element, such as whether it's numeric or text, and it's stored on each element and whether the data element can be left empty or must have a value. A database management system, or DBMS, is a collection of programs that manages the database structure and controls access to the data stored in the database. In a sense, a database resembles a very well-organized electronic filing cabinet in which powerful software, which is your DBMS, helps manage the cabinet's contents. The DBMS serves as the intermediary between the user and the database. The database structure itself is stored as a collection of files, and the only way to access the data in those files is through the DBMS. The DBMS retrieves all application requests and translates them into the complex operations required to fulfill those requests. The DBMS hides much of the data's internal complexity from the application programs and the users. The application program must be written by a programmer using a programming language such as Visual Basic, Java, or C#, or it might be created through a DBMS utility program. Having a DBMS between the end user's applications and the database offers some important advantages. First, the database management system enables the data in the database to be shared among multiple applications or users. Second, the DBMS integrates the many different users' views of the data into a single all-encompassing data repository. So it shows you several end users here in this slide, and then it shows you the DBMS that connects to all the users, and then the database structure itself is viewed through the database management system so that many users can send their requests to the DBMS to the database structure itself. DBMS provides many advantages. Improved data sharing. This means the DBMS helps create an environment in which end users have better access to and better manage data. Such access makes it possible for end users to respond quickly to changes in their environment. Improved data security. The more users access the data, the greater the risk of data security breaches. So corporations invest considerable amounts of time, effort, and money to ensure that corporate data are used properly. A DBMS provides a framework for better enforcement of data privacy and security policies. Better data integration. Wider access to well-managed data promotes an integrated view of the organization's operations and a clearer view of the big picture. It becomes much easier to see how actions in one segment of the company affect other segments. Minimize data inconsistency. Data inconsistency exists when different versions of the same data appear in different places. For example, data inconsistency exists when a company's sales department stores a sales representative's name as Bill Brown, and the company's personnel department stores that same person as William G. Brown, or when the company's regional sales office shows the price of a product as $49.95 and its national sales office shows it at $43.95. The probability of data inconsistency is greatly reduced in a properly designed database. Improved data access. The DBMS makes it possible to produce quick answers to ad hoc queries. From a database perspective, a query is a specific request issued to the database for data manipulation. For example, to read or update the data. Simply put, a query, queries are questions in a spur-of-the-moment question is your ad hoc query. The database management system sends back an answer called the query result set to the application. For example, when dealing with large amounts of sales data, end users might want quick questions answered. Something like, what are the dollar volume of sales by product during the past 6 months? What is the sales bonus figure for each of our salespeople during the past 3? How many of our customers have credit balances of $3,000 or more? And your database can process these questions when they're presented in the correct query format and give you the answers back. Improved decision making. Better managed data and improved data access make it possible to generate better quality information on which better decisions are based. The quality of the information generated depends on the quality of the underlying data. Data quality is a comprehensive approach to promoting the accuracy, validity, and timeliness of the data. While a DBMS does not guarantee data quality, it provides a framework to facilitate data quality initiatives. Increased end-user productivity. The ability of data combined with the tools that transform data into usable information empowers end users to make quick, informed decisions that can make the difference between success and failure in our global economy. Okay, sorry for the interruption. Now let's discuss types of databases. A database management system can be used to build different types of databases. Each database stores a particular collection of data and is used for specific purposes. The number of users determine whether the database is classified as single or multi-user. A single-user database supports only one user at a time. A single-user database that runs on a personal computer is called a desktop database. In contrast, a multi-user database supports multiple users at the same time. When the multi-user database supports a relatively small number usually less than 50, or a specific department within an organization, it is called a workgroup database. When the database is used by the entire organization and supports many users, 50 plus, usually into the hundreds, across many departments, the database is known as an enterprise database. Location might also be used to classify the database. For example, a database that supports data located at a single site is called a centralized database. A database that supports data distributed across several different sites is called a distributed database. Both centralized and decentralized, or distributed, databases require a well-defined infrastructure, hardware, operating systems, network technologies, etc., to implement and operate the database. Typically, the infrastructure is owned and maintained by the organization that creates and operates the database. But in recent years, the use of cloud databases has been growing in popularity. A cloud database is a database that is created and maintained using cloud data services such as Microsoft Azure or Amazon's AWS. These services provide third-party vendors provided defined performance measures such as data storage capacity, required throughput, and availability for each database, but do not necessarily specify the underlying infrastructure to implement it. The data owners does not have to know or be concerned about what hardware and software is being used to support their database. The performance capabilities can be renegotiated with a cloud provider as the business demands or the database changes. In some contexts, such as research environments, a popular way of classifying databases is according to the type of data stored in them. Using this criterion, databases are grouped into two categories: general purpose and discipline specific. General purpose contains a wide variety of data used in multiple disciplines. For example, a census database that contains general demographic data, and the LexisNexis and ProQuest databases that contain newspaper, magazine, and journal articles for a variety of topics would be considered general purpose databases. Discipline specific contains data focused on specific subject areas. The data in this type of database are used mainly for academic or research purposes within a small set of disciplines. Examples of discipline-specific databases include financial data stored in databases such as CompuSat or CRSP, geographic information system databases that store geospatial and other related data, and medical databases that store confidential medical history data. The most popular way of classifying databases today is based on how they will be used and on the time sensitivity of the information gathered from them. For example, transactions such as product or service sales, payments, and supply purchases reflect critical day-to-day operations. Such transactions must be recorded accurately and immediately. A database that is designed primarily to support a company's day-to-day operations is classified as an operational database, also known as an online transaction processing, transactional, or production database. In contrast, an analytical database focuses primarily on storing historical data and business metrics used exclusively for tactical or strategic decision making. Such analysis typically requires extensive data massaging or data manipulation to produce information on which to base pricing decisions, sales forecasts, market strategies, and so on. Analytical databases allow the end user to perform advanced data analysis of business data using sophisticated tools. Typically, analytical databases comprise two main components: a data warehouse and an online analytical processing front end. The data warehouse is a specialized database that stores data in a format optimized for decision support. The data warehouse contains historical data obtained from the operational databases as well as data from other external sources. Online analytical processing is a set of tools that work together to provide an advanced data analysis environment for retrieving, processing, and modeling data from the data warehouse. In recent times, this area of database application has grown in importance and usage to the point that it has evolved into its own discipline, business intelligence. The term business intelligence describes a comprehensive approach to capture and process business data with the purpose of generating information to support business decision making. Databases can also be classified to reflect the degree to which the data are structured. Unstructured data are data that exist in their original raw state, that is, in the format in which they were collected. Therefore, unstructured data exists in a format that does not lend itself to the processing that yields information. Structured data are the result of formatting unstructured data to facilitate storage use and the generation of information. You apply structure or format based on the type of processing that you intend to perform on the data. To further illustrate the concept of structure, imagine a stack of printed paper invoices. If you want to merely store these invoices as images for future retrieval and display, you can scan them and save them in a graphic format. On the other hand, if you want to derive information such as monthly totals and average sales, such graphic storage would not be useful. Instead, you could store the invoice data in a spreadsheet format so that you can perform the required computations. Actually, most data you encounter are best classified as semi-structured, which means they have already been processed to some extent. For example, if you look at a typical web page, the data are presented in a prearranged format to convey information. The data types mentioned thus far focus on the storage and management of highly structured data. However, corporations are not limited to the use of structured data. They also use semi-structured and unstructured. Just think of the valuable information that can be found on company emails, memos, and documents such as procedures, rules, and web pages. Unstructured and semi-structured data storage and management needs are being addressed through a new generation of databases known as XML databases. Extensible markup language is a special language used to represent and manipulate data elements in a textual format. An XML database supports the storage and manipulation of semi-structured XML data. Database design refers to the activities that focus on the design of the database structure that will be used to store and manage end-user data. A database that meets all user requirements does not just happen. Its structure must be designed carefully. In fact, database design is such a crucial aspect of working with databases that most of this book is dedicated to the development of good database design techniques. Even a good DBMS will perform poorly if it is a badly designed database. Because current generation DBMSs are easy to use, an unfortunate side effect is that many computer-savvy business users gain a false sense of confidence in their ability to build a functional database. These users can effectively navigate the creation of database objects, but without the proper understanding of database design. They tend to produce flawed, overly simplified structures that prevent the system from correctly storing data that corresponds to the business realities, which produces incomplete or erroneous results when the data are retrieved. Understanding what a database is, what it does, and the proper way to use it can be clarified by considering what a database is not. A brief explanation of the evolution of file system data processing can be helpful in understanding the data access limitations that databases attempt to overcome. Understanding these limitations is relevant to database designers and developers because database technologies do not make these problems magically disappear. Database technologies simply make it easier to create solutions that avoid these problems. Creating database designs that avoid the pitfalls of earlier systems requires that the designer understand these problems and how to avoid them. Otherwise, the database technologies are no better than the technologies and techniques they are trying to replace. To be successful, an organization must develop systems for handling core business tasks. Historically, such systems were often manual paper and pencil systems. The papers within these systems were organized to facilitate the expected use of the data. Typically, this was accomplished through a system of file folders and filing cabinets. Generating reports from these manual file systems was slow and cumbersome. In fact, some business managers faced government-imposed reporting requirements that led to weeks of extensive effort each quarter, even when a well-designed manual system was used. Therefore, a data processing specialist was hired to create a computer-based system that would track data and produce required reports. Okay, so basic file terminology that you guys need to know is your data is your raw facts such as telephone numbers, birth dates, customer names, year-to-date sales values. Data have little meaning unless they are organized in some logical manner. So a field is a character or group of characters that has a specific meaning. A field is used to define and store your data. A record is a logically connected set of one or more fields that describes a person, place, or thing. For example, the fields that constitute a record for a customer might consist of the customer's name, address, phone number, date of birth, credit limit, and unpaid balance. And a file is a collection of related records. For example, a file might contain data about the students currently enrolled at Gigantic University. Alright, if we go back to slide 16, so they want to do data processing. They want to make it easier, so they hire these data processing specialists to create computer-based systems to update their manual systems, where it'll make it easier to process their data. The user's desire for direct hands-on access to data helped to fuel the adoption of personal computers for business use. Although not directly related to file system evolution, the ubiquitous use of personal productivity tools can introduce the same problems as the old file systems. Personal computer spreadsheet programs such as Microsoft Excel are widely used by business users, and they allow the user to enter data in a series of rows and columns so the data can be manipulated using a wide range of functions. The popularity of spreadsheet applications has enabled users to conduct sophisticated data analysis that has greatly enhanced their ability to understand the data and make better decisions. So here it shows sales department and the personnel department, and a linking for a simple file system. You have your file management program, you have your file report programs, and then you have your sales files and your customer file there that links to both programs. And then on the other side you have your personnel department and your agent file that links to both programs. So your problems with file system data processing. The file system method of organizing and managing data was a definite improvement over your manual system of just papers in a filing cabinet. And the file system served a useful purpose in data management for 2 decades or more, a very long time in the computer era. Nonetheless, many problems and limitations became evident in this approach. A critique of the file system method serves 2 major purposes. It helps you to understand the shortcomings of the file system and enables you to understand the development of modern databases. Many of the problems are not unique to file systems. Failure to understand such problems is likely to lead to their duplication in a database environment, even though database technology makes it easy to avoid them. Okay, so we're going to discuss problems associated with file systems, whether created by a DP specialist or through a series of spreadsheets, severely challenge the types of information that can be created from the data as well as the accuracy of the information. Alright. Lengthy development times is a problem. The first and most glaring problem with the file system approach is that even the simplest data retrieval task requires extensive programming. With the older file system, programmers had to specify what must be done and how to do it. As you will learn in upcoming chapters, a modern database uses a non-procedural data manipulation language that allows the user to specify what must be done without specifying how. Difficulty of getting quick answers. The need to write programs to provide even the simplest reports makes ad hoc queries impossible. DP specialists who worked with mature file systems often received numerous requests for new reports. So they were often forced to say that the report will be ready next week or even next month, and if you need the information now, next week, or next month, it's useless to you. A complex system administration. System administration becomes more difficult as the number of files in the system expands. Even a simple file system with a few files requires creating and maintaining several file management programs. Each file must have its own file management program that allows the user to add, modify, or delete records, to list the file contents, and to generate reports. Alright, lack of security and limited data sharing. Another fault of a file system data repository is a lack of security and limited data sharing. Data sharing and security are closely related. Sharing data among multiple geographical users introduces a lot of security risk. In terms of spreadsheet data, while many spreadsheet programs provide rudimentary security options, they are not always used, and even when they are, they are insufficient for robust data sharing among users. In terms of creating data management and reporting programs, security and data sharing features are difficult to program and consequently are often omitted from a file system environment. And then extensive programming. Making changes to an existing file structure can be difficult in the file system environment. For example, changing just one field in a customer file will require a program that reads a record from the original file, transforms the original data to conform to the new structure storage requirements, writes the transformed data into the new file structure, and repeats the preceding step for each record in the original file. In fact, any changes to file structure, no matter how minor, forces modifications in all of the programs that use the data in that file. A file system exhibits structural dependence, which means that access to a file is dependent on its structure. For example, adding a customer date of birth to a customer file will require the 4 steps that we just talked about in extensive programming. Given this change, none of the previous programs will work with the new customer file structure. Therefore, all the file system programs would have to be modified to conform to the new file structure. In short, because the file system application programs are affected by changes in the file structure, they exhibit structural dependence. Conversely, structural independence exists when you can change the file structure without affecting the application's ability to access your data. Even changes in the characteristics of data, such as changing a field from integer to decimal, requires changes in all the programs that access the file. Because all data access programs are subject to change when any of the file's data storage characteristics change, the file system is said to exhibit data dependence. Conversely, data independence would exist when you can change the data storage characteristics without affecting the program's ability to access data. The practical significance of data dependence is the difference between the logical data format, which is how human beings view the data, and the physical data format of how the computer must work with the data. Any program that accesses a file system's file must tell the computer not only what to do, but how to do it. Consequently, each program must contain lines that specify the opening of a specific file type, its record specification, and its field definitions. Data dependence makes the file system extremely cumbersome from the point of view of a programmer and database manager. In file system structures makes it difficult to combine data from multiple sources, and its lack of security renders the file system vulnerable to security breaches. The organizational structure promotes the storage of some basic data in different locations. Database professionals use the term islands of information for such scattered data locations. The dispersion of data is is complicated by the use of spreadsheets to store the data. In a file system, the entire sales department would share access to a sales data file through the data management and reporting programs created by the DP specialist. With the use of spreadsheets, each member of the sales department can create his or her own copy of the sales data. Because data stored in different locations will probably not be updated consistently, the islands of information often contain different versions of the same data. This is where data redundancy comes into play, because the data exists and is stored unnecessarily in different places. Uncontrolled data redundancy sets the stage for poor data security. Having multiple copies of data increases the chances for a copy of the data to be susceptible to unauthorized access. Data inconsistency. will most definitely exist when different and conflicting versions of the same data appear in different places. Data entry errors are more likely to occur when complex entries are made in several different files or recur frequently in one or more files. Data anomalies. The dictionary defines an anomaly as an abnormality. Ideally, a field value change should be made in only a single place. Data redundancy, however, fosters an abnormal condition by forcing field value changes in many different locations. A data anomaly develops when not all of the required changes in the redundant data are made successfully. So, update anomalies. For an example, if agent Leah F. Hahn has a new phone number, it must be entered in each of the customer file records in which Ms. Hahn's phone number is shown. In this case, only 4 changes must be made. In a large file system, such a change might occur in hundreds or even thousands of records. Clearly, the potential for data inconsistency is great. Insertion anomalies. If only the customer file existed and you needed to add a new agent, you would add only a dummy customer data entry to reflect the new agent's addition. Again, the potential for creating data inconsistencies would be great. Deletion anomalies. If you delete the customer, Amy O'Brien, George Williams, and Olette Smith, you will also delete John Oaken's agent data. Clearly, this is not desirable. Alright, so a new problem that has evolved with the use of personal productivity tools is that users typically lack proper design and data modeling skills. People naturally have an integrated view of the data in their environment. Data modeling skills are also a vital part of the design process. It's important to document the design properly. Design documentation is necessary to facilitate communication among the designer, the end user, and the developer. Data modeling, as introduced later in the text, is the most common method of documenting database design. Using a standardized data modeling technique ensures that the data model fulfills its role in facilitating communication. The data model also provides an invaluable resource when maintaining or modifying a database as business requirements change. The problems inherent in file systems make using a database system desirable. Unlike the file system with its many separate and unrelated files, the database system consists of logically related data stored in a single logical data repository. Because the database's data repository is a single logical unit, the database represents a major change in the way end-user data is stored, accessed, and managed. A database's DBMS provides numerous advantages over file system management by making it possible to eliminate most of the file system's data inconsistency, data anomalies, data dependence, and structural dependence problems. Better yet, the current generation of DBMS software stores not only the data structures, but also the relationships between those structures and the access path to those structures, all in a central location. The current generation of DBMS software also takes care of defining, storing, and managing all required access paths to those components. So, contrasting a database and a file system. In a file system, you have your personnel department, and it has their employee information. You have your file system sales department with customer sales and inventory information. You have your accounting department with your accounts. With a database system and a DBMS, you can combine your database, your employees, your customer sales, your inventory, your accounts, everything into one centralized database structure, and all 3 departments can access that structure. And here again, it shows how everything can link together, and you can have multiple end users for your database system, and all of your data sent in and stored together for easier access And with everything stored in one location and everybody can access that one location, you don't have the inconsistencies and the anomalies like you will in a file system with multiple versions stored all over the place. Alright, the term database system refers to an organization of components that define and regulate the collection, storage, management, and use of data within a database environment. So your functions of your DBMS. A database performs several important functions that guarantee the integrity and consistency of your data in your database. Most of these functions are transparent to end users, and most can be achieved only through the use of the DBMS. They include data dictionary management, data storage management, data transformation and presentation, security management, multi-user access control, backup and recovery management, data integrity management, database access languages, and application programming interfaces, and database communication interfaces. So if we start with data dictionary management, the DBMS stores definitions of the data elements and their relationships in a data dictionary. The DBMS uses the dictionary to look up the required data component structure and relationships, thus relieving you from having to code such complex relationships in each program. Data storage management. The DBMS creates and manages the complex structures required for data storage, thus relieving you from the difficult task of defining and programming the physical data characteristics. A modern DBMS provides storage not only for the data, but for related data entry forms or screen definitions, report definitions, data validation rules, procedural code, structures to handle video and picture formats, and so on. Data storage management is also important for database performance tuning. Performance tuning relates to the activities that makes the database perform more efficiently in terms of storage and access speed. Data transformation and presentation. The DBMS transforms entered data to conform to required data structures. The DBMS relieves you of the chore of distinguishing between the logical data format and the physical data format. That is, the DBMS formats the physically retrieved data to make it conform to the user's logical expectations. Security management. The DBMS creates a security system that enforces user security and data privacy. Security rules determine which users can access the database, which data items each user can access, and which data operations, such as read, add, delete, or modify, each user can perform. Multi-user access control. To provide data integrity and data consistency, the DBMS uses sophisticated algorithms to ensure that multiple users can access the database concurrently without compromising integrity of the data. Backup and recovery management. The DBMS provides backup and data recovery to ensure data safety and integrity. Current DBMS systems provide special utilities that allow the database administrator to perform routine and special backup and restore procedures. Recovery management deals with the recovery of the database after a failure, such as a bad sector in the disk or a power failure. Such capability is critical to preserving the database's integrity. Data integrity management. The DBMS promotes and enforces integrity rules, thus minimizing data redundancy and maximizing data consistency. The data relationships stored in the data dictionary are used to enforce this data integrity. Ensuring data integrity is especially important in transaction-oriented database systems. Data integrity and transaction management issues are discussed later in the book. Database access languages and application programming interfaces. The DBMS provides data access through a query language. A query language is a non-procedural language, one that lets the user specify what must be done without having to specify how. Structured Query Language, or SQL, is the de facto query language and data access standard supported by the majority of DBMS vendors. And as we get more into working with the actual databases, we'll work with SQL. Database communication interfaces. A current generation DBMS accepts end-user requests via multiple different network environments. For example, the DBMS might provide access to the database via the Internet through the web browsers such as Mozilla, Firefox, or Google Chrome. In this environment, communication can be accomplished in several ways. End users can generate answers to queries by filling in screen forms through their preferred web browser. The DBMS can automatically publish predefined reports on a website. The DBMS can connect to third-party systems to distribute information via email or other productivity applications. Although database systems yield considerable advantages over previous data management approaches, database systems do carry some significant disadvantages, such as increased cost. Database systems require sophisticated hardware and software and highly skilled personnel. The cost of maintaining the hardware, software, and personnel required to operate and manage a database system can be substantial. Training, licensing, and regulation compliance costs are often overlooked when database systems are implemented. Management complexity. Database systems interface with many different technologies and have a significant impact on a company's resources and culture. The changes introduced by the adoption of a database system must be properly managed to ensure that they help advance the company's objectives. Because database systems hold crucial company data that are accessed from multiple sources, security issues must be assessed constantly. Maintaining currency. To maximize the efficiency of the database system, you must keep your system current. Therefore, you must perform frequent updates and apply the latest patches and security measures to all components. Because database technology advances rapidly, personnel training costs tend to be significant. Vendor dependence. Given the heavy investment in technology and personnel training, companies might be reluctant to change database vendors. As a consequence, vendors are less likely to offer pricing point advantages to existing customers, and those customers might be limited in their choice of database system components. Frequent upgrade replacement cycles. DBMS vendors frequently upgrade their products by adding new functionality. Such new features often come bundled in new upgrade versions of the software. Some of these versions require hardware upgrades. Not only do the upgrades themselves cost money, it also costs money to train database users and administrators to properly use and manage the new features. Some database career opportunities that you can be thinking about is a database developer. They create and maintain database based applications. Some skills that are required is programming, database fundamentals, and SQL. A database designer designs and maintains databases. Their skills would be system design, database design, and SQL. Database administrator, manage and maintain a DBMS and databases. Database fundamentals, SQL, and vendor courses are skills that are required. A database analyst develops databases for decision support reporting. SQL, query optimization, and data warehousing is some skills that are required. Database architects, design and implementation of database environments, conceptual, logical, and physical. Skills required, DBMS fundamentals, data modeling, SQL, some hardware knowledge. A database consultant helps companies leverage database technologies to improve business processes and achieve specific goals. Skills required is database fundamentals, data modeling, database design, SQL, DBMS, hardware, vendor-specific technologies. Database security officer implement security policy for data administration. DBMS fundamentals, database administration, SQL, data security technologies are all skills that are required. Cloud computing data architects design and implement the infrastructure for next generation cloud database systems. Internet technologies, cloud storage technologies, data security, performance tuning, and large databases are some skills that are required. So that concludes the lecture for Chapter 1 and databases. If you guys have any questions or any problems with any of the information, let me know, and I'll get back to you as quick as I can to try to clarify things.